Hi everybody, it's Miss Elkins. I've got some notes here to review you about graphing and tables. Let's first talk about the coordinate plane. If you don't have notes to fill in at home, you can just go ahead and write down whatever you think is, write down the important stuff in these notes. You can rewatch these notes or rewind them as you need to get things if you missed anything. But this is important information that you need to know and understand for our next Unit 8 test. So, the coordinate plane includes two perpendicular meaning that they intersect at a right angle, two perpendicular number lines, the word is number lines, that intersect at the what is called the origin, or also known as the point 0, 0. The horizontal number line is called the x-axis. The vertical number line is called the y-axis. Those are important things that you need to know. Ordered pairs. Each point on the coordinate plane can be described by an ordered pair, which determines the location. Ordered pairs are written with a parentheses, a number x for the x-coordinate, and a number for the y-coordinate, and then a closed parentheses. You have to put the parentheses, you have to put the comma. The x always has to go first and the y always has to go second. Those things are non-negotiable. Where the first value describes the x-coordinate, and the second value describes the y-coordinate. Okay, so those are two things you need to know. Ordered pair and coordinate planes. You need to know what an origin is, what an y-axis, x-axis, x-coordinate, and y-coordinate is. All right, so let's talk about this graph right here. This graph is only quadrant 1 of a graph. It is not the all 4 quadrants like we normally see. And so all of our ordered pairs will be positive numbers because they are only on the positive part of the graph. So let's look for the circle. Let's see, here's the circle right here. The circle is here. And on the x-axis, which is always the horizontal line, it is located at the number 2. On the y-axis, it is located at the number 8, both positive. We write the circle's ordered pair as 2 being the x-coordinate and 8 being the y-coordinate. Now next we'll do the triangle. The triangle is right here and its x-coordinate is 8 and its y-coordinate is 5. So we write the coordinates of that, the ordered pair for that, as 8, 5. Have to put the parentheses, those are non-negotiable. That means you can't leave them off. If you don't put the parentheses around it, it's just 2 numbers. It has to have the parentheses. Now we go to the square. Whereas the square is up here, and on the x-axis, it's located at 9. And also on the y-axis is located at 9. We couldn't get this wrong if we tried because both of the x and the y are 9. Okay, and let's try another one. I'm changing my color of my pen so you can see. We're going to the hexagon. Hexagon meaning a 6-sided figure. Looks like the hexagon is located at 4 on the it's located at 4 on the x-axis and 3 on the y-axis. So we write that ordered pair as 4, 3. Now we have a pentagon. The pentagon is located, well, it's the 5-sided figure. The pentagon is located at the coordinate 3, 4. So that is written, that ordered pair is written as 3, 4. Now, trapezoid, it almost looks like a triangle, but it's not. It's a trapezoid. The trapezoid is right up here at where x equals 10 and y equals 4. The ordered pair, the coordinates of the trapezoid are 10, 4. And then the last one is the rhombus. And the rhombus is actually not in a coordinate. It's on the y-axis. As you can see, it's at where x is 0 and y is 5. So we would say that it's on the y-axis because it's at 0, 5. All right, so that's how we write the ordered pairs to go with those different shapes on that coordinate graph. Okay, now it says describe the difference between the ordered pairs for the hexagon and the pentagon. Well, the hexagon and the pentagon have the same numbers, but they're reversed, which puts them in a different location. So the numbers are reversed. You cannot switch out the x and y coordinates, or you will wind up putting your points in the wrong place or naming them the wrong location. So the x coordinate has to go first, the y coordinate has to go second. But if you notice that the hexagon and the pentagon have the same numbers, but they're in different locations, that's because the x is different and the y is different. Okay. Describe where on the coordinate plane the ordered pair 0, 7 would be. I'm sorry, 7, 0. I said that backwards. Oh, okay, so if you had 7, 0, that dot would be located on the x-axis because you're not going up. You're just going over to 7 and staying on 0 on the y-axis. So that stays on the x-axis. All right, I'm going to turn this paper over. Plotting ordered pairs from a table. A lot of times we're going to be given a table and we're going to be putting those numbers from the table onto a graph. So here's a very important point that I must make over and over again. The left column in a table always represents the x values. Always. The left column is always the x values, while the right column is always the y values. Now, I say that although you may be given different letters, we know that the x values are the independent values and the y values are the dependent values, and that's what we're really talking about here, but we're going to get into that more tomorrow. But just know that the horizontal line is always going to be the values in the left column, and the vertical line will always be the values in the right column from a table. In a horizontal table, the x values are on the top and the y values are on the bottom. This is super important. Don't forget this. If you have to stop and write this down word for word, then stop and write this down word for word, because that is very important. You'll be given a table and you'll be asked to see which ones are the x values and which ones are the y values. Only they'll be calling it dependent and independent, which we'll learn about tomorrow. All right, so graph the following points. Be sure to notice the scale on each axis and label any necessary details. So on this first set, number 3, we have x values of 5, 10, 15, 20, 25, 30. We have y values of 15, 30, 45, 60, 75, and 90. So we need to graph those on the coordinate grid right beside it. And again, this is only a positive one because most of what we'll be working with graphing will be positive numbers. Later on, you'll get into more negative numbers. So the x, as I said earlier, is always the horizontal line. The y is always the vertical line. So to plot this first point, we're going to look for 5 here on the x, and we're going to look for 15 on the y, and we're going to put a dot where those two lines intersect. And since there isn't anything to call that, we're going to go ahead and name it the point that it's labeled 5:15. Don't usually just put dots on a graph. We usually label them some way. And if there's no label, we put the numbers on there. Okay. Then we're going to do the same thing with 10 and 30. 10 goes right here. 30 is right here. There is the point 10 and 30 from our table. And then 15 and 45. 15 and 45 would be right here. Now I don't know why they put these numbers in the table because they don't fit on our graph. 25 and 75, it only goes up to 50 on the y-axis, so there's no way we could graph those. If the graph was much bigger, we could, but this one's small, so it won't fit. Hey, number 4, same thing. The top values are your x values, the bottom values are your y, the horizontal is your x, the vertical is your y. Oh, this is not numbered. We're going to have to number it. I'm going to have to zoom way in to number it. And before I number it, I'm going to look at the numbers on my table. The x values are 3, 6, 9, 12, and 15. And the y values are 12, 24, 36, 48, and 60. I'm not going to try to guess what would fit. I'm just going to use these numbers as my x values on the bottom. So I'll just start going by threes. So it'll be 3, 6, 9, 12, 15. I'm going to make my pen skinnier. 15, 18, 21, 24, 27. I have to go to the end even though I don't need it. I'm going all the way to 30. And then I have to fix these because, well, I just do. 3, 6, 9, 12, 15. Okay, so there's my bottom numbers. The vertical numbers, the y's, are going to go by, it looks like 12s. So I'll do that on this side. We'll start with 12, or let's start with 6. I'll go by half. So 6, 12, 18, 24, come on, slide down, 30, 36, 42, 48, 54, and 60. There, now every point will fit on that graph. So I'll put the first numbers on here. X is 3 and Y is 12. That'll go right here. 3, 12. Okay, the next value, 6 and 24. We'll go right here and I'll label that 6 and 24. Then 9 and 36. This makes it easy. You can see that those numbers are going to go up pretty evenly, especially the way that we numbered it. So that will be labeled 9, sorry. That'll be 9 and 36. And then we'll go to 12 and 48. And we'll label that 12 and 48. And then we'll go to 15 and 60. And that's our last point. Oops, that's on here. 15 and 60. Graphs won't always be labeled for you, but if you're making a graph for me, I'd like you to label it. So there's one more thing that we forgot to do, because this table is named minutes and rotations. So we need to label the bottom of our graph minutes. And then we need to label the y-axis rotations. If it's not labeled or designated as something, I can't be sure that you know what you're doing. So always label your X and Y according to what your table says. Now this one, the table was just X and Y, so we just had to put X and Y. But this one was labeled minutes and rotations, so we needed those words there. Okay. Last one is about donuts. Donald's Donuts sells sprinkled donuts. At the end of the day, Mr. Donald attempts to determine how many donuts were sold, but has some missing details. Use the information in the table and the graph to help him. Now, this graph doesn't have a lot of information on it, but it does show us that this is the number of donuts on the X, and this is the cost in dollars on the Y. And it looks like, according to this table, that 3 donuts cost somewhere between $5 and $10. It's not $5 and it's not $10, but it's somewhere right in the middle. We'll come back to that. The table shows us that 5 donuts cost $12.50. So that looked like it would be somewhere in this range, right? And then we're missing the 7 on our graph and on our table. But looks like it'll be somewhere between $15 and $20, right? Because this table has to go up the same each time. Let's see if it helps us to look all the way at the end of our graph. At the end of the graph, we have 15 donuts. Cost somewhere between $35 and $40. Oh, but 12 donuts, if you notice, cost $30. I'd like you to think for a minute of how you might figure out how much one donut cost. I'll wait here while you think of it. Did you think of something? Oh, divide the total cost by the number of donuts. We could do that with these two numbers right here, couldn't we? So let's take the total cost, $12.50, and divide it by 5. 5 will go into 12 twice, because 5 times 2 is 10. No 2 left over. 5 will go into 25 5 times, and there's nothing left over but a 0, which will go up top. Oh, it's $2.50 a donut. So if it's $2.50 a donut, how much is 7 donuts? Oh, well, it's $5 more than it would be for 5 donuts. How did I do that in my head so fast, you wonder? Well, I thought about 2 times $2.50 would be $5. And that 7 is 2 more than 5. So this would be $17.50. How many donuts would cost $20? Oh, I'm going to have to say it's got to be 8, because if you look at the graph over here, somewhere between 6 and 9 is 8. And I believe that we would find that that would be, because we know it's not 7, right? And it's not 9, because 9 donuts is not on the graph. 9 donuts would be more than $20. That'd be like $22.50. So 8 donuts cost $20. 12 donuts, that's on the graph. 12 donuts cost $30. You can see that here. 12 donuts, $30. And then 20 donuts isn't on the graph, but if they're $12.50 for 5, we can multiply $12.50 times 4, or we could just add $12.50 4 times, because 5 times 4 is 20. And what we're going to find is that for 20 donuts, it cost $50. If you have questions about how I came up with that, email me and we'll do a Google Meet, because it would be easier for me to explain to you in person than it would be through an email. Okay. All right. So I'm not going to summarize today's lesson, but you kind of get the idea. We've learned how to take a table and put it on a graph, or we can look at the information on the graph to fill in the table. So today's practice will be something like that. There is a practice page for you, a practice Google Slides for you in Schoology today, so you can work on that. And email me if you have any questions. I'll be happy to set up a Google Meet anytime between 2 and 4:30 if you need more one-on-one. I'll be happy to help you. Hope you have a great day. Hope you're not feeling bad. I'll see you soon, I hope.